So before I show you the tools I've built, I'd like to tell you about the thinking behind this project. Before moving to Lancaster County, lived in New York City, Brooklyn actually, although this is a picture of Soho. And I chose this picture. This is a good illustration. Here, New York City and Lancaster County both have lots of hills. The thing about a big city like New York is the topography is obscured by all the buildings, right? So it's hard to really get the lay of the land, except if you look over here at the roadways. So the roadways, unless you're looking at a bridge or an elevated highway, is going to give you an idea of the natural topography of the land. And if you ride a bicycle, for example, you don't care how steep a building is, but you do care about the roadways. So I thought it would be cool to take the roadway network in a city and combine that with a digital elevation model to get build a 3D roadway. One question I run into, though, is how to show this 3D roadway, how to show the changes in elevation. And my original thought was to build a map book. It turns out that it is not as easy to symbolize 3D vector data as it is to do for raster data. Raster data, it's easy to build a shaded relief map, but 3D vector data, not so much. But fortunately, ArcGIS has a tool which is a great way to look at this data. And the tool is ArcScene. So let's start by pulling up a 3D road file I already created for Harrisburg. All right, there it is. Now, not very exciting at the start until we do something to make the elevation changes more obvious. So we go into the properties of the layer, and right here, elevation from features, factor to convert layer elevation value to scene units. So this defaults to 1. But if we give this a value like, say, 4 or 6, let's do 6, and OK. Now, you can see that it exaggerates changes in the topography, and so things are, whoa, there we go. Okay, now we can get an idea, exaggerated idea, but it makes it easy to spot. And if we use a consistent ratio, then we can compare different cities and get a sense of how they compare as far as hilliness. Okay, so now that we've seen what the payoff will be for building a 3D road shapefile, let's show how my tools can actually do this. So, to import my stuff. And it also displays some, when I import this, it displays some reminders for me of things that I want to do to handle situations like city names with spaces in them, because I create files based on those city names, and that can cause problems if there's spaces or dashes in the cases of Wilkes-Barre. Okay, so build city 3D roads. Let's try Mechanicsburg, because I haven't done that yet. Okay. Now, I don't have the shapefile for roads in this county. The roads, you can download shapefiles for the roads that are a single file for an entire county from census.gov. So since I haven't done that county before, I have to go ahead and do that, download it from census.gov. That runs pretty quickly. The rasters are slower, and it unzips it. Now, it couldn't find mechanicsburg.tif because I haven't tried to create a mosaic of rasters for Mechanicsburg before. So it is selecting Mechanicsburg and clipping off from a tile index to find out what files will need to be downloaded. So, and now it says there will be 6 tiles required, and it's likely that none of them are on my hard drive yet. So, go ahead and try and download the first one from Pasta. And so the rasters, like I said, that will take a while to download. So I will pause recording and come back when it's almost done. So I'll just let the first one run here. Well, you'll see the last one anyway, just a minute. Okay, we're back. I've been downloading and I have started recording again just for this last one. So you get a sense of how long it takes to download a zipped raster tile from Pasta. So the program automatically, if the zip file isn't on the hard drive, it downloads it, then it unzips it, and once that is done, it uses the same list that told the computer what needs to be downloaded and goes through that list. And here you can see the call to Mosaic New Raster Management. This is building a mosaic with those rasters. So we have one nice file for, in this case, Mechanicsburg, which encompasses the city boundaries. And now we're calling Interpolate Shape 3D, which is taking that roads network that we clipped off the county. And here we have it, Mechanicsburg 3D roads.shp. And if I go back into ArcScene and just quickly say a new thing, don't need to save changes, and add, we should now see Mechanicsburg 3D roads. There we go. Add. And once again, make it look a little more obvious where any changes of elevation are. I would like to be able to automate this part, but ArcScene doesn't have as many hooks as ArcMap. Okay, so now it's a little more. Let's even give it a little bit more in this case. This isn't, we wouldn't want to do that. We'd want to be consistent between different cities if we're trying to sort of compare. But let's go ahead and jack things up a bit. There we go. And I just want to center this and zoom in a bit. Whoop, there we go. There. So if you're already familiar with the roadways in a city, then you would actually be able to orient yourself. In cities like Pittsburgh are a lot of fun because it's very obvious, if you've been there, what your orientation is because of all the rivers and bridges. I got a kick out of looking at Pittsburgh. Go, and that. And so once again, let's change the properties and bring this to, Pittsburgh is already pretty hilly, so let's just try 4. Yeah, that's going to be plenty. Zoom in. And so there you can really get a sense of those steep bluffs. Yeah. And the thing is, since these are roads and not buildings, you can also get a sense of that the downtown area is relatively flat. right? So, okay. So now let's go into ArcMap because, as I said, my first plan was to make a map book, but to show elevation of roadways, but I realized that that works well for rasters, but that really for vector data, ArcScene is a much better way to do it. But I didn't want to just abandon map books altogether. So now the thing is, this is just proof of concept, really. You could get, you can easily get a map of a city using Google Maps, or if you're using ArcMap, data-driven pages is typically how to do this kind of thing. But my emphasis with my tools is automating getting the data, getting data that you need to, specific kinds of data, whether you're building 3D road networks or whatever. I'm interested in automating that aspect. And if you're automating that aspect, then it's easy to just add code to do exactly what you want once you've got the data for each different geographic area. So let's go ahead and import. So we're just in a Python window within ArcMap. And my usual reminders. Okay, so now build city, and I can actually even just, that's the nice thing about the Python window. And let's try and do Reading. Okay, so it is getting the creating a map document object in a data frame. Now it is creating, it loaded the roads, created a buffer of 10 feet on each side of the road center line. So we get a nice visual of the road. Now from high up, I chose yellow to color the roads just so they pop out because the lines are very narrow. And then again, this is proof of concept, so I just pick the center area of the city and zoom in so that it's big enough so that the labels fit on the roadway buffer. And that should pop into view in a little while. It's sort of funny how the road lines show up before it zooms in. So there we have it. Just a close-up view, imagery base map, and some labeling. Labeling is a little messy, but like I said, this is just proof of concept that this could be done. And you don't have to, I automate clearing out the layers, so you don't have to do anything but just build a map for a different city. Let's try Quarry though. I forget if I've done that already or not. So it's going to delete the layers off the table of contents there. And good, I guess the PDF doesn't already exist. I would give a message saying the PDF file already exists if it did. Yeah, I didn't say that these are exporting to PDF automatically. So there we go. So here's the high-level view of Quarryville with the roads, and then you can see the roads before the underlying imagery pops into view. There we go. There it is. And we can take a quick look at the actual PDF I created here. So, I say map, but it's not really a map. It's just a an image from high above. So the road network in yellow, and then if we look at the center, which is not guaranteed to be downtown, it's just the centroid, basically, I guess, of the city boundaries. And here is a little random area with street labels. And you can see that those are buffers overlaying the imagery. So it's looks more graphic than photographic. Okay, so let's get out of here and go into a Python window, because I want to show you the code. Not in huge detail. I don't want to go into great detail on each line, but just to give just an overview of a top level, just to so we have some idea of how I approach things. So I've built some utilities too, just to pull up an editor without having to click around with the mouse and stuff. So here we are. Let's go to the build 3D roads. There we are. Here's the function, build city 3D roads. So the main steps for this function are, first, check if there is already a 3D shapefile for this city, in which case we just give an error message saying it exists already and return. But if we haven't called this function before to build it, then it goes to clip city roads. This is where it actually looks for the county road file and clips off using the boundaries of this city. And it does that all using a Pennsylvania municipalities shapefile, which I actually selected out cities and boroughs and saved that to a separate file, separate shapefile. Then it goes and checks if it calls build city DEM. This function checks if DEM already has been created for the city, and if not, it creates it, and we'll look into that in a bit more detail. And then once we have the roads and the DEM, then we can combine them with the interpolate shape function to actually create the 3D shapefile. And it just checks that that file exists after this function was run, meaning the function successfully created it, and it returns the path name. Okay, so we'll look in a little more detail at build city DEM, which is right there. Once again, first thing it does is check if there's already a DEM file for the city, if we've already run the program for the city before, and if so, it gives a message and returns. Get city DEM list function looks at a shapefile that is a tile index for Pennsylvania. I built it out of two, one for the north half and the south half. I just glued them together to build a single tile shapefile, and it selects the city, and it does a join operation between the select city layer and this shapefile. And what that does is it pulls off all the tiles that it will need to get to build a raster for this city. And each of these tiles has actually an attribute, which is an FTP URL address where you can download the raster. You can see where the cursor is, where I get the length of the list that came back from that, so I can tell the user how many DEM tiles will be needed. So if none of them are already on the hard drive, the user has some idea of how long it's going to take to do this. Then we call the assemble tiles function, which actually looks for each of those rasters in the list, and if they are not already on the hard drive, then it downloads them as needed from POSDA. Then we get to the raster mosaic function, which is just really a wrapper that I wrote around the argpy function that does the work of gluing together all the rasters in the list into a single raster that is then, we give it a file name matching the city and store it on our hard drive. So then we have one nice clean raster file for the whole city. So I could drill down deeper and talk more about the code, but I know that for myself, I like to look at code at my own pace. So I'll stop now. I learned as I went while doing this and found, especially for automating the download of data, I needed to use PIP to get some additional Python libraries. In fact, let me take a quick look here. And yeah, there it's in this file, package installs.txt. Okay, so here are some packages. I think the only ones I needed for this project was httplib2 and pathlib. But also, since I'm doing a lot of automated handling of data, I keep stuff organized in various folders on my computer, and I've had time to make this work, but not time to make a whole package that could make it work on someone else's computer. Although if there's interest in this, I may put more time into this to do that, to have a program that would automatically use pip to get libraries that are needed and create a whole directory structure and all that. But that's a separate matter. So I guess that's all I have to say. Thanks for watching.